foreign Voyager turned its camera back towards Earth, creating what is essentially Earth's first ever selfie. That picture, taken decades ago, depicted a pale blue dot. For decades, Voyager 1 has been journeying through space, delivering unprecedented information. Every discovery seemed impossible until scientists reviewed the data and confirmed their reality. Recently, Neil deGrasse Tyson announced that Voyager 1 detected 500 objects passing by in space, a finding that changes everything. Join us as we uncover what Voyager's message really means and how it might change space exploration forever. Voyager 1, launched back in 1977, has been cruising through space for nearly half a century. Despite its age, this spacecraft is in remarkable condition and usually operates smoothly. However, it was recently caught off guard, leading to strange behavior. To provide some perspective, Voyager 1 is currently over 14.5 billion miles away from Earth and travels at a rate of about 3.6 times the distance between the Earth and the Sun per year. This is impressive for a spacecraft that has been out there for so long. The mysterious objects Voyager 1 detected are fascinating, as it spotted 500 unknown objects passing by in space, things we have never seen or identified before. This discovery was unexpected, making it even more astonishing. One possibility is that the spacecraft's age is catching up with it. Launched in 1977, Voyager 1 circuitry is around 45 years old, so it would be understandable if the computers didn't work the same way anymore. However, this hasn't been the case so far. A key aspect of the spacecraft's longevity lies in its dual redundant computer systems. Each Voyager spacecraft features two sets of command computer subsystems, Flight Data Subsystems, FDS, and Altitude and Articulation Control Subsystems. This redundancy allows for seamless transitions between systems and the activation of dormant computer components, preserving their lifespan. To maximize efficiency, Voyager's instruments relied on hardwired logic due to power budget limitations and time constraints during the spacecraft's development. Electrical engineers devised simplified systems using hardwired logic. Voyager 1 and its twin, Voyager 2, have 6 onboard computers organized as a distributed system with 3 dual redundant pairs. Maintaining Voyager 1's operational integrity involves ongoing power management, crucial for sustaining its computer systems given the limited power resources onboard. Engineers have implemented measures to conserve and optimize power usage. One notable power management aspect is the selective powering down of non-essential systems. Engineers systematically identify and deactivate components or subsystems that are not vital for primary mission objectives. For instance, heaters associated with certain science instruments have been switched off to reduce power consumption, thereby extending the spacecraft's lifespan. Deactivating non-essential systems involves careful evaluation of trade-offs between power conservation and scientific objectives. Engineers work with scientists to determine the impact of deactivating specific systems on data quality and availability, aiming to strike a balance that maximizes power efficiency while maintaining necessary functionality for gathering valuable cosmic information. Voyager 1 adapts its power management strategies to changing environmental conditions. As it travels farther from the Sun, the available solar energy decreases, prompting the spacecraft to adjust its power usage. This adaptive approach ensures efficient power resource allocation for critical operations and data transmission. Ongoing technical advancements and improvements in power management have allowed engineers to refine Voyager's power systems over the years. Enhancements include more efficient power distribution, improved battery charging methods, and advancements in power regulation and control. These meticulous power management strategies have extended Voyager 1's operational lifespan, enabling it to continue its scientific journey through space. Careful power resource allocation ensures that critical systems remain functional, allowing the spacecraft to transmit valuable data and insights back to Earth for as long as possible. Considering the spacecraft was only supposed to last for 5 years, it's astonishing that it is still sending back information nearly 50 years later. This longevity results from the meticulous work and skill of scientists who have ensured the spacecraft's continued functionality. However, this doesn't mean that unexpected events can't happen in open space. Deep space is inherently unpredictable, but we generally have some idea of how things will be. Typically, we expect spacecraft to interact with meteoroids, asteroids, and space rocks. However, Voyager's message about detecting 500 objects was unexpected, raising significant concerns. Researchers working on the project termed this an anomaly because the signals were unexpected, and there was no clear way of understanding what was happening. Voyager 1 started transmitting mysterious telemetry data back to Earth, yet the spacecraft remained responsive to commands from mission control, albeit with a slight communication delay. Voyager 1's antenna continued to point towards Earth, ensuring effective command reception and execution. While scientists were puzzled by the mysterious data, Voyager 1 appeared to be functioning correctly and continued to gather and transmit data. The anomaly did not trigger any onboard fault protection systems, designed to activate when anomalies are detected, putting the spacecraft into a safe mode for engineers to investigate. Voyager 1 continued its operations without entering safe mode, deepening the mystery. After careful investigation, the anomaly was traced back to the Altitude and Articulation Control Subsystem, AACS, responsible for orienting the spacecraft and controlling its movements. The AACS had been sending telemetry data through an onboard computer that had ceased functioning years ago, leading to data corruption. To fix this, the mission team instructed the AACS to redirect telemetry data to the appropriate functioning computer. This low-risk fix was successfully executed. However, the significant time delay in communication, due to the spacecraft's vast distance from Earth, posed a challenge. Voyager 1 is approximately 14.6 billion miles away from Earth, so it takes about 22 hours for radio signals to travel this distance. When NASA's Deep Space Network sends a command to Voyager 1, it takes 22 hours to receive a response, requiring careful planning and precise execution of commands. The Deep Space Network, DSN, includes 3 stations: Goldstone in California, Madrid in Spain, and Canberra in Australia. These stations' strategic placement ensures continuous coverage and observation of spacecraft as Earth rotates. The DSN is the largest and most advanced scientific telecommunication system worldwide, facilitating two-way communication between Earth and deep space missions. Utilizing radio wave transmission, the DSN's colossal antennas send and receive signals, establishing a vital link between Earth and distant probes. For Voyager 1, the DSN typically uses channel 18, with frequencies of 2.3 GHz or 8.4 GHz for data transmission and 2.1 GHz for signals from Earth to the spacecraft. Even at the speed of light, the signal takes 22 hours to reach the spacecraft. This time delay poses unique challenges for the mission team, requiring careful crafting of commands and anticipating response times. The anomaly was fixed by shutting down the faulty computer, but the reason why the AACS started routing telemetry data to the incorrect computer remains a mystery. It is suspected that the AACS received